course.
What are we with?
Yeah, from one class, not two. You had a week to study last week.
A lot of things.
You had 9 days to study last week.
You have half the book chemistry to study.
No, you had a quarter book of chemistry because you still have semester two.
Oh, okay.
Right. Um, physics. 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 Our new chapter now. Okay. So we're looking at electricity. Oops. Charge and current. Okay, so this uses a little bit of what you learned in chemistry. Am I recording? Oops. Okay. Right, so from chemistry or even basic middle school science, you may remember that charge is something electrons, protons, and other particles have. And think back to middle school in chemistry, you've learned that electrons, we say, are negatively charged, and protons are positively charged. This I will not talk about in detail because you're doing chemistry. Okay, so you would have done this in chemistry, positive and negative charge. You've done that already, haven't you? So things that are negatively charged and things that are positively charged pull or attract each other. Again, you know this from basic science. Electrons and protons are pulled towards each other because an electron is negative and a proton is positive. Electrons and electrons, they are repelled. And protons repelled also. So if they have the same charge, they push away, and if they have opposite charges, they attract. You don't even need to write this down because this is so basic. You know this from chemistry and middle school. Now, into a definition now. So when I say electric current, what I mean is a movement or a flow of charge. So there's a current if there's a charge moving. Yep. You got that? So, for example, when we have a current in a metal, if there's a charge moving in a metal, copper, whatever, it's because there are free electrons in the metal that move. And again, you might remember this from chemistry. I think even Lorraine would describe it as an ocean of electrons. There's free electrons in the metal that move, and this is how the charge moves. So there's the picture of it there. Electrons are moving in the metal wire. So there's the negative charge is moving, so we say there's a current. Now, electrolyte, have you done this in chemistry or not? Electrolyte? No. An electrolyte is a chemical that conducts electrical current. Normally a battery is an electrolyte. I go one step at a time. So you don't have use metals to move a current, to move a charge.
You just use the electrons of the
Yeah, but what I mean is you don't need to use metal solid to have a charge moving. You can use actually some liquids. So for example, I think it's something like if you just add, I think you just add salt to water, you could have a current in this, you could have a charge moving in this. So anyways, electrolyte is a chemical that conducts current. It's usually used in batteries to make ions flow. Now, does anybody know what an ion is from chemistry? What's an ion?
charge.
It's a charged atom. So you don't need to write down what an ion is if you know it from chemistry. You did it in chemistry, didn't you? Ions? So I just said an ion is atoms which have an extra electron or a missing electron, but it's okay. So you normally see electrolytes in batteries. So an electrolyte, it is the ions that move to make the current instead of an electron. So you could have a positively charged atom moving. This is a current as well. Okay, you got that? Yeah? You don't need to write the rest down. So here's a little picture from an example here. So have you done H2SO4 in chemistry? Do you know what it is? Does anyone know H2SO4? Yeah, what is it? It's an acid. It's a very strong acid. This acid here, when you put zinc and copper into the acid, the H2SO4, you can see the bonds break. The SO4 goes towards the zinc, and then I can't see on my laptop. Here is SO4 moving there, and then here you can see two hydrogen, and the zinc moves from here over to the copper. So anyways, all you need to know is, you see the hydrogen has a little plus on it. That means the hydrogen is missing an electron, it has a positive charge. So what is built, can you see that there are little pluses here? So what's happening here is the hydrogen positive charge is moving towards the copper, and the copper now has a positive charge on it. So there's a positive charge, positive ions going towards the copper. That's what's happening here. Yeah, actually I think it'll turn green then, and you'll start to see it build up on top of the copper. I think it's like a greeny colour. You did it before?
No, I thought of that.
You saw it, yeah. Okay. So, by the way, which way is the current flowing here? Do we say it's from positive to negative? So is it going around this way? Or do we say the current goes from negative to positive? Because here, I've just said, in the last picture, positive goes to the copper here. Does anyone know, do we say positive to negative, or do we say negative to positive?
Positive.
In the battery? Positive to negative, or negative to positive? Positive to negative? Negative to positive? Well, actually, it's both. So you have to be very careful with your language here, okay? The electrons actually move in the opposite direction to where we say the current moves. So for example, that is from negative to positive, no question mark there. If an electron moves from A to B, so be very clear about this, if an electron moves from A to B, we say there's a current flowing from B to A. Yes, B to A. Even though the electron is flowing from A to B. So I know this seems very odd, but if an electron moves from here to here, we say the current flows from this one to this one here. So just to be clear with your English, you have conventional current, which is the one we normally use, But electron flow is the opposite direction, okay? So please be careful about this in the exam. Current and electron flow are opposite directions. So we say the current goes from positive to negative, even though the electrons move from negative to positive.
Reverse the question.
Huh?
Reverse the question.
No, no. So I'll say that one more time because it's important. If an electron goes from A to B, we say a current flows from B to A, even though the electron is moving from A to B. Now you don't need to, all you need to write actually or do is draw the picture will be enough. With the names, current and then electron flow. So see here, the current goes from positive around to negative, or even though the electrons are going from negative around to positive. So please draw this will be enough. Okay. So you might be wondering why this is. It seems silly. Shouldn't we say the current flows from A to B if the electrons flow from A to B? And the answer is actually because we call electrons negative and protons positive. In fact, it really should have been called the other way around. We really should have said electrons are positive and protons are negative. But because we call electrons negative and protons positive, this is the reason why it looks ridiculous in the last picture. The reason we have this situation is because we call electrons negative and protons positive. This is the reason why. But it would be too difficult just to start saying electrons are positive. This will confuse people. But you must understand it doesn't matter which you call positive or negative, okay? If I call this left and this right, and then tomorrow I call this right and this left, as long as everybody does the same thing, there's no problem. Okay? I call this left and call this right. If I call this right and this left and everybody does the same thing, then there's actually no problem. It doesn't matter, it's the same for positive and negative. If we call electrons positive and protons negative, and if everybody does that, then there's actually no problem. In the same reason, there's no problem if I swap left and right. But this is not the case. Unfortunately, we call electrons negative and protons positive, and I think we can have Benjamin Franklin to thank for that. So the reason for this is, Benjamin Franklin with the kite in the lightning storm? You know this person? Anyway, the reason for this is just because when people were first studying this, they didn't know what electrons or protons were. They called the electron part the negative part. It would have been better if they called it positive. They had a 50-50 chance, and they just picked the wrong name, and unfortunately that's the reason why we have the diagram with the two possibilities. So there's nothing that can be done about it now. You just need to remember if the current goes from A to B, the electrons flow from B to A. You just have to remember it. Okay, so now on to some definitions. So when we're talking about current, we need a way to measure current, and the way we measure current is with the amp. So the definition of the amp is quite a difficult definition. So before I give you the definition, just please remember, if two things have the same charge, Do they attract or do they repel? The same charge, they repel. Okay? So if you have two currents, remember current is just a charge that's moving. So if you have two currents, you have two charges that are moving. If these charges are moving close together, they should feel a force. Which way should they feel the force? Outwards. Yeah. So in fact, if you have two wires close together with the same current, they should bend a little bit outwards because their charge are the same. Outwards. Yeah, outwards. Outwards. This is inwards and this is outwards. Yeah. So they should bend outwards. So the definition, I'm very sorry, it's a very technical definition and a picture here will help. We say we have 1 amp of current in each wire if, when they're 1 meter apart, they produce this much force. Now, here the diagram is attractive. That's actually a bad diagram. They really, if they want to attract, then one needs to be going up and the other one needs to be going down. Doesn't matter. So the force here is 2 times 10 to minus 7. This is just a definition. It's a very technical definition. You can try to remember it in words, or for me, it's much easier to picture the picture here. When you have 2 amps, 1 amp on the left and 1 amp on the right, and when they're 1 meter apart, this is how much force you should have. This is when you know you have 1 amp. This is the definition of 1 amp. It's a technical definition. Please write it down carefully. You could get it in the exam. Also the picture here. I need to fix that picture. Got that now? Not yet. Got it? Yes, I need to go on now. Have you got it?
Yeah.
Yep. Okay. So the Coulomb, have you done Coulomb in chemistry? I don't think you use it in chemistry. The Coulomb measures charge. So basically, if I can just go to the side here for a moment, if you have a current of 1 amp, what that means is you have 1 coulomb of charge moving per 1 second. So, for example, here's our positive charge. 1 amp means you have 1 coulomb per 1 second. So every second, 1 coulomb of charge comes out. So a coulomb is how much charge you have with 1 amp in 1 second, basically. And actually, as a formula, you can write it like this. Charge is current multiplied by time. Total charge, current, and time. Q equals IT.
Finishing?
Yeah, you need this also for the exam. Total charge transported. Okay, you got that definition? Yeah. So, how big is 1 coulomb of charge? Well, it's actually pretty big. So to give you a scale, 1 electron has a charge of only minus 1.6 times 10 to the minus 19 coulombs. So coulomb is pretty big because 1 electron has this much charge, minus of course. And in fact, proton has the same charge as an electron, so a proton would be 1.6 times 10 to the minus 19 coulombs. Do you use coulombs in chemistry? I don't think so, no? In fact, because this is quite common in physics and in chemistry, we often just use the letter E to represent this number here. It's on your calculator. If you look at your calculator, and if you look at the constant, it's constant number 23. Shift 723. Type that in please on your calculator. Shift 723. Shift, not yours, Tekken 30. Shift 723. Okay, did you find it on the calculator? Not yours either. What's wrong? What's wrong? Did you press shift 723?
Yeah, that's fine.
Yeah. So what's your question?
That calculation on range mode in the
Shift mode degrees. You got it? Yeah. So, in a chemistry, what do you say the charge of 1 electron is? What do you say the charge of 1 electron is in chemistry? What do you call the charge of 1 electron? check.
Like they call it like the mass.
No, they don't call it the mass.
Like the okay, you have the charge -1.
Yeah, -1. So in chemistry, you would say the charge of one electron is -1. And in physics, we say it's this. -1.6 times 10 to the -19 coulombs.
And in chemistry, that's what they call the mass.
The mass. The mass of an electron is -1. Are you sure? It's a
They
big...
don't put the minus there, just it isn't.
Yeah, the charge of an electron is 1. Are
So
you
what is
sure?
it?
This seems very fishy to me.
No, like they just say the mass is this.
The mass of what?
The mass of the electron.
Is 1.
No, 1.6 times 10 to the power minus 19.
No.
Then for
It's
the
not, it's not, it's not. The
neutron
mass of, no,
is
it's not.
0.
The mass of an electron is much smaller than this. It's like 10 to the minus... It's like 1 point... No, it's like 9.19 times 10 to the minus 27 or something. I'll tell you right now, mass of an electron is 9.11 times 10 to the minus 31. You might be mixing it up with some other number. Okay. Right, so, did you have this formula written down?
Yeah.
Right, so write this question down. You have a 100 milliamp current flowing through some copper wire for 2 seconds. What is the total charge that moved during the 2 seconds? Milliamps, yeah. Right, let's have a look. So, what you have here, well actually it's almost the same picture. The time is 2 seconds. And here is our copper. And there's electrons moving through it. And the electrons come out. And I want to know how much charge is coming out, how much charge is moved. So the formula is charge equals current multiplied time. And the current is, what did I say it was? 200 milliamps? 100 milliamps. So that's 100 milliamps. So that will be 100 times 10 to the minus 3, multiply the time, which is 2. So that will be 200 times 10 to the minus 3 coulombs, or in other words, 200 millicoulombs.
So why is it
It
minus
wasn't
3?
over,
Milliamps.
How milli or
Milli, yeah.
it wasn't over.
Huh?
Q is equal to I over T.
Q is equal to IT. I sure hope that's what the formula I gave you said. Yeah, Q equals IT. Got that? So, yeah, that's it. In 2 seconds, how much charge comes out? 200 millicoulombs of charge comes out after 2 seconds. That's it. So, I mean, you can take a picture of this if you want, but there's only one formula for this lesson. Q equals IT. So all these formulas, Q equals IT. you want to take a picture on your phone or not? No? I'll upload it after class. The test tomorrow is a 1 hour test.
1 hour?
Yeah,
1 hour.
thanks.
Do you want me to make it a 2 hour test?
No.
No, you don't. Trust me, this is better for you, 1 hour test.
Oh, that's good.
It means less questions, not more questions.
I see.
I'll give you 1 hour to do 10 short questions. So when I mean a short question is, I mean no parts, just question. That's it, no ABC part.
Yeah, that's okay.
Yeah. So you'll have 10 of these to do in one class, 50 minutes tomorrow. It could be anything up to and including this lesson. What do you mean what?
Even this.
Yeah, even this.
Is there?
Yeah. Yeah.
Okay. But from the homework they said, right?
Yeah, there'll be questions taken from the homework.
That's okay.
Yeah, so it could have a question like this. No, okay, I won't include this because I won't have time to do them before the test. Well, I mean I will, but it wouldn't be fair. So look, everything in mechanics could be on the test tomorrow. 10 short questions to do in 50 minutes. And this is important. You need to bring your laptop.
Tomorrow.
Yeah, because the test will be a computer test.
Oh.
You'll have to type the answers in.
Computer test.
Yep. You type the answers in.
Oh.
This way you get your results after the test.
Wow.
Exactly after the test.
Yeah, because it's computerized test.
Ah.
So you type it in and you get the answer. Now please wait, actually just before you go, just when you're typing in your answer, okay, let me give you an example. Suppose your answer was 2/3 meters, okay? You can type your, you could do it like this, 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 or you could even type it in like this. Of all these ways, the only way I want you to type it in is just the number, okay? Don't put the unit at the back, don't type x equals, don't type fractions, and definitely don't type x equals fractions and units, okay? I only want you to type your answers in like this. 3 significant figures. 1, 2, 3. Okay? If you get the last one wrong, that's okay because there'll be a plus or minus 0.01 allowed. Okay? So 3 significant figures. You can be 1 off in the last significant figure is acceptable for this test. Okay, please let Sophie, Amanda and Grace, please tell them to bring their laptops tomorrow because I'm sure they'll be in the chemistry test now. That's why they skipped this class to prepare for it. Because they're going to watch this video later. I know you're at home right now preparing for the chemistry test. Because I'm going to walk through there and I'm going to see them sitting down there. Guarantee it.